Hello, calculus fans. Let's talk about higher derivatives. So we're thinking about second derivatives and third derivatives here. If you have a function of two variables, then its partial derivatives, fx and fy, are also functions of two variables. And that means you could take derivatives of those guys. So you could have fx x, fx y, fy x, and fy y. Those are called the second partial derivatives of f. If z is equal to f of xy, we have lots of other notations for second partial derivatives. These are the various notations that we might use. The most common ones that I think that we'll use in this class will be these guys here, and I suppose these guys here. The notation fxy, or d squared f over dy dx, means that we first differentiate with respect to x and then with respect to y. And now this is not a typo. I have fxy, but in the Leibniz notation, the denominator says dy dx. That's not a typo. That means x first, then y. And that's because this is an operator notation. When we compute fyx, it's reverse order. So as an example, let's find all of the second partial derivatives of x cubed minus 5x to the fourth y cubed minus 4y squared. Now earlier we computed the first partial derivatives. They look like this. So now fxy means we should take fx and differentiate that with respect to y. And if we do that, we get negative 60x cubed y squared. Whereas if we want to compute fyx, we have to take fy and differentiate that with respect to x. And if we do that, we again get negative 60x cubed y squared, even though we did the derivatives in the opposite order. So notice that in this example, we get the same thing for fxy and fyx. This is not a coincidence. With almost all nice functions that we run into, this is going to be true. That's a consequence of something called Claro's theorem, which says that if you have a function that's defined on a disk that contains some point, and the mixed partial derivatives fxy and fyx are both continuous, then they will be the same. fyx at AB will equal fyx at AB. And you can just take it as a given for this class that just about every time you have nice functions, it won't matter which order you compute the partial derivatives, so compute them in the order that you think is most convenient. Okay, that's all for now.